You should form project groups of 1, 2, or maximum 3 persons. Okay? You can choose any topic from the list I proposed, or you can take ideas from the news forum posted on Moodle, or you can propose a subject you want, but it should be related to the course content. Okay? So please, as soon as you decide what is the project you want to work on, tell me, because sometimes subjects are not available since other groups already reserved them. Okay, so try to finish this issue for this week. Okay, and hopefully we can say that at the end of October I am expecting that you can start to present your project. Now today we will go over like an introduction of ways of creating energy. Okay, and we will look together at some videos which will help you in understanding more the material. So, and I will post directly after the session, I will post the links for YouTube videos and the PowerPoint, and it will be also recorded for you, so you can hear the voice if you want. Okay, so to start with, so do you see my screen now?
Yeah, we have it, doctor.
Okay. Okay. So in this chapter, we will introduce the energy science. You have some history in this chapter, but don't worry, you don't have to remember anything. So it's just an introduction for you to know how the use of energy was changing with history, but no need to remember any dates, anything, just understand the main idea. Okay? So the discovery of fire created an irreversible shift in the balance of nature. It was one of the most important inventions which help in creation of energy, since, as you know, fire will create thermal energy, and thermal energy can be then transformed into several other modes of energy. So mainly in this course, we will see what are the techniques to change from one form of energy to the other. Okay, so for example, we will see that in turbines, we will transform, let's say, kinetic energy of a flow, okay, into mechanical energy of rotation. Or for example, in a pump, we will transform the rotational energy into flow energy, which will increase the pressure of a flow. So you will see that using different mechanisms, we can change from one form of energy to the other. Okay, and the creation of fire was the discovery of fire was very important, since thermal energy. What I mean by thermal energy, so it's heat. You are using heat, okay, and heat, as we will see, can be transformed into work, which will be through mechanical energy, which also can be converted after to electrical energy. So all these types of energy are connected, and we can simply, by using some machines, we can go from one type of energy to the other. Now, in the last 2 centuries, humankind discovered how to change heat obtained from fossil fuels into electricity. So you can start to see the link between the different modes of energy. So from fire first, we are burning fossil fuels, and then we can convert heat that is produced from burning fossil fuels into electricity. We will see how in this course, and electricity is the most important form of energy, which allowed a very rapid advances in science and engineering, and made life much more comfortable for us. Okay, so over the last 2 centuries, since the start of the Industrial Revolution, a significant fraction of the fossil fuel reserves of Earth that took hundreds of millions of years to be formed have been depleted. And this is a very important problem that we will learn how to overcome in this course. Because fossil fuel reserves are not renewable. When I say renewable energy, this means that I can get it again, like solar energy. It's always available, it's free, okay? Fossil fuels need a lot of time to form, and you will see how they form in this course. So when we consume them, we need a lot of time to have fossil fuels again, okay? This is why we have a problem that we should shift from energy use using burning of fossil fuels. We should find new forms of energies that are first more available, that are renewable, and what is very important also, that we should find methods that are not harmful for the environment, because the combustion of fossil fuels, as you will see, will generate CO2, which is a pollutant for the environment. In addition, it contributes to the global warming effect that we will see in detail in this chapter, okay? So there is a lot of disadvantages in using fossil fuels, so we should try to look at engineering strategies to come up with new techniques to produce energy while having less harmful effects. So in 1 year, we are consuming what took about 1 million years to lay down when we are talking about fossil fuels. And this is associated with the release back into the atmosphere of large amounts of greenhouse gases. And you will see what here in this chapter, what is greenhouse gases. And you will see that they have a very harmful effect on the environment, okay? So the threat to life on Earth is very strong. Unless we raise up to the challenge and find more efficient techniques of energy use and rely, as we said, on more renewable sources. So to achieve this, we need to obtain a good understanding of energy issues based on the basic principles, challenge assumptions, and look for creative solutions. So this is what we will do in this course. We will first understand the physics of how to transform energy from one form to the other. And then we will look at what sources are the cheapest one, are environmentally friendly, and can be used efficiently, okay? So as we will see, we will go over solar energy, which is very important, wind energy. Nuclear energy was very used, but now it's very limited because it can lead to very harmful effects, okay? So we will go over all of these techniques in this course. Now we will go to the basic forms of energy transformation from one form to the other, okay? One of the main engineering techniques for transformation of energy is water engineering using Archimedes screw principle. What is Archimedes screw principle? It's very simple, okay? It's just rely on creating, if I can create the rotation of a shaft, I am able to pump water from rivers for irrigation, or I can higher the level of water. Why? Because in this way, I will transform the rotational mechanical energy into potential energy, which will help me to lift water upward. And this has a lot of applications. So I can use, as we said, to pump water from rivers for irrigation. I can use it to clear water from flooded area. I can use it to empty grain from ships. So it has several applications. Now to see it in live, I will show you a video, and all videos links will be posted for you on Moodle, okay? So for each chapter, I will post for you on Moodle a list of YouTube links that will help you to understand the main principles we will talk about. So for example, for Archimedes screw principle, you have two small videos that will show you how this will work. So if we go over them, can you see the video now?
Yes.
Okay, so look, here I just have to produce rotation of this shaft, and in this way I can lift water from low level to very high level. So as you can see here, okay, by having several screws and rotating them, I can lift water from the low level to the higher level. Okay, and we have a second video that is a real one that will show you a real application. So you will see in this video that you can do the rotation manually. Okay, of course you can have a motor producing rotation, but it can be also doing manually, as you can see here. So by just producing the rotation of the screw, the mechanical energy will be transferred to water, and this will be transferred to a potential energy form that will allow water to be lifted upward. Okay, and now you will see when you stop the rotation, then water will fall back, because in this case you will have that the potential energy will be transformed into rotation. Okay, so when the water will go down, it will give its energy, its potential energy will be transmitted to mechanical energy, and it will rotate the screw in the other direction. Okay, now another important invention is water wheels. Water wheels can convert the energy of falling or moving water into mechanical energy. Okay, we will see that we have two types of water wheels. It can be undershot and overshot water wheels. What is the difference? The only difference is the position of water relative to the wheel. So sometimes in rivers you have a flow of water. So here you have the flow of water is going under the water wheels, and you will see that the kinetic energy of the flow will be transformed into rotational energy of the wheel. So here you are transforming kinetic energy into rotational energy. Another possibility is overshot water wheels. In this case, you draw water from the upper side, and then when falling down, the potential energy of water will be transformed into rotational mechanical energy. Okay, and also we will see videos on how water wheels function. So first here we will see a real application, how a water wheel is. So this is undershot water wheel. This wheel, as you can see, can pump water to villages, because it will then transform the rotational energy into pressure flow, okay, into pressure energy, which will pump water to for irrigation purposes or to reach any place you want. And what is nice about this, that it's very simple, so you don't have complex mechanical equipment, so it needs low maintenance, and it can be used for irrigation purposes, as we can see. So just you have here the kinetic energy of the flow, okay, that will rotate the wheel, and then in the wheel you have a mechanism that will allow you to transform the rotational energy into increase in pressure of water to pump it for irrigation use, or to take it from a place to another. So you can pump water over nearly a mile without electricity using this technique. And this is very used in many countries. Now we will look at other videos that will physically explain for you how the energy is transformed from one form to the other. The voice of the video is clear for you or not?
No.
Okay,
No,
so
doctor.
I will stop the voice and I will explain for you directly while you are looking at the video. Okay? So here we will see how the flow of energy will be transformed into rotational energy. Okay, and then it will be used to pump water. So for example here, first, as you can see, water will go under the wheel and the kinetic energy of the water will produce rotation of the blades. Now, in order to pump water, the water wheel should be related to another small mechanical mechanism, okay? So as you can see, the water wheel, as it is rotating, it is attached to a system of gears, okay? And the system of gears, as will be shown, will be attached to through a connecting rod. So as you can see, you have a loosely attached connecting rod to the gear, and this rod is linked to two pistons that are moving in a translational way. So here you are converting the rotation of the water wheel to translation of the piston. And you will see that for these two pistons, they will play the role of first, one piston will suck water, while the other will deliver water at higher pressure. So if you look at the figure here, in each chamber, you have two valves, as we will see. One will be open to suck water, and then in the second phase, water will be pumped. So if you look at the figure, here are the two valves, okay? And you can see that the two pistons are doing the opposite motion. So now, once this valve is opened, we will see that water will be sucked into this chamber, and then the valve will be closed, and when the piston will move back, water will be discharged at a higher pressure. So in this way, we have transformed the rotational energy of the wheel into a mechanical energy that will increase the pressure of the flow. Please stop me if you have any question, okay? If something is not clear, directly ask me. Let me check your chats. Okay. Now we will look, we have seen that we have undershot and overshot water wheels. So let us look at the other application, which is overshot wheels. So here you will see how the potential energy of the water flow will be transformed into rotational mechanical energy. So mainly I will focus on this part because this is the most important one for us. Okay, so we will see here that water will flow from this level. So you have a flow of water, and when going down, then the potential energy of water will be transformed into mechanical energy of rotation of the wheel. Okay? And now, how we can calculate the power that is produced from this case? Okay? We can go back to the formula of power. What is power? Is the change of energy per unit time, or it can be calculated as the change in pressure times the flow rate. Why I am saying this? So look, you have water is flowing over the water wheel and it's going down. As it is going down, it's losing gravitational potential energy, because you know, higher is your object, higher the gravitational potential energy that is stored in. Okay? So, because look at this very simple example. If you have an object and let's say you place it at a very high level from the ground, if you release it, it will go down. When you release it, the potential energy stored in this object will be transformed into kinetic energy as it will fall down. This is why more you fall down, higher will be your velocity. Because when you fall, your potential energy is transformed into another type of energy, which is kinetic energy. And kinetic energy is related to the velocity. It's equal to half mv squared. Okay? And in these types of wheels, the gravitational potential energy will be converted into rotational energy, because the water will flow on the blades of the water wheels and it will rotate. Now, the rotational energy, as seen in the previous example, can be converted through a mechanical equipment to another form of energy. So, for example, you can convert it, as in the previous case, or to increase the pressure, or you can convert it in a straight line kinetic energy, as you did for the piston in the other example. Okay? Now, if you want to calculate the power created by falling water, you should go back to the basics. Okay? We know that power is energy per unit time. And energy, what is the unit of energy per unit time? It's watt, or joule per second. Okay? To calculate energy, you have several formulas. And now we will use the formula that is convenient for our case. Okay? So in our case, what do we have? We have water flowing over the water wheel. So the change in potential energy will create the power that we have. Okay? Now, for example, you have several units for power. In general, we work with watt, which is the most familiar one, which is the SI unit. But also we have units as horsepower, and you can directly convert from one unit to the other by a simple proportionality factor. Okay? Now, let's go over the details of calculation of power. If I want to write here, by definition, power is equal to energy per unit time. Okay? So as units, I have it's equal to joule over second. Okay? Which is equivalent to what? Now, in another formula that can give me power is that power is equal to force times velocity. Okay? Why? Why I can write it like this? Because energy, by definition, okay, energy is equivalent in unit to work. If you have to produce a work, okay, what should you have? You should have a displacement. So work is defined as F times D. So the unit of energy is the same unit as F times D. Okay? Now, if you want to obtain power, you should divide by time. But what is distance over time? Distance over time is nothing than V. Okay? This is why power can be obtained by F times D over T, where F times D is unit of work or energy, which is joule. And when I divide by time, I get joule per second. So F times V will give me the unit of power, which is what? Now, in case I have pressure variation, I can replace F by delta P or P pressure, okay, times area, because you know that a force, the unit of a force is the unit of pressure times unit of area times V, okay? But what is A times V? I think you know it. It's the flow rate, okay? Because P, so the unit of P is Pascal. It's pressure. So pressure, it's Newton per meter square. So it's equal to Newton per meter square, okay? Your area on which you are applying the pressure is in meter square, and the velocity is in meter per second. Now, if you multiply the cross-sectional area by V, this corresponds to the flow rate, okay? So this term is called A times V. A times V is called the flow rate. In general, we annotate it in mechanical engineering as Q, okay? So Q is the flow rate, and it's in meter cube per second, okay? So now, in my problem, power is created from the potential energy of water, okay? And potential energy is calculated as, so the potential energy is given by rho, okay, times G times the head, okay? What do we mean by the head? The head is the variation in elevation of water, okay? So as water will flow, okay, you have that the pressure, this is the pressure created by it, rho GH, okay? So if you want, this is potential energy, but if you want, I should multiply it by something else to become an energy. I should multiply it by m dot, okay? So here I'm just talking about variation in pressure. So my variation in pressure, is equal to rho G times the head, rho G delta H, okay? Because as my water will flow down, I will have a certain pressure variation, which is rho G times H, which is called the head, okay? So this will give me the expression of P, and then when I multiply it by Q, when I multiply this by Q, so times Q, I will obtain power, okay? Because power is P times Q. And now, if you go back to your definition, so you have the head, the density of water, the rate of flow, the gravity, and you multiply by the efficiency of the wheel. Why you multiply by the efficiency of the wheel? Because any system will involve losses. So you don't have a perfect system. Always you have losses, and the efficiency is always lower than 100%. Any question on this?
No.
Okay.
Complicated, doctor.
It's complicated. Crystal,
Yes.
what's your major?
Law.
Look, I am ready to help you anytime you want. I know that you might find this a little bit complicated. So you can
Okay.
contact me when you want to give you more details, okay?
Okay, thank you. Thank you, doctor.
Welcome. Okay. So we are done with this. This is for water wheels. So let us continue. We will go over the slides. Okay. Now, so we will continue with the history of energy technology. In 1832, one very important invention is Fourneron turbine. Okay, And this turbine consists of set of guiding vanes that direct the jet of water towards blades of a rotating wheel. The design of this turbine permitted to capture the kinetic energy of the jet more efficiently. And after this invention, we have a lot of advances in hydropower as one of the major electricity generation techniques, because we will see that one of the main purpose of turbines is to create the rotational energy. And once you create rotational energy, you can attach your turbine to a generator. And the rotational mechanical energy will be converted by the generator to electrical energy. So this invention was very important. And to have a certain more idea about how this turbine functions, I also prepared for you a video showing how this will happen. So here you have in order the ideas as in the slide. So first we talked about Archimedes principles, then water wheels, then the hydraulic turbine, the first hydraulic turbine. Okay, so here you should know that this turbine consists mainly of two sets of blades. Okay, one is fixed and the other is moving. So and they have opposed directions. We will see why. Okay, so first, as you will see here, you have a jet of water, for example, that is going down on the blades. So first, the fixed blades will convert part of the pressure flow of water into kinetic energy. So in a first phase, you will convert the pressure of your flow into kinetic energy. So the velocity will increase. This is when going through the fixed blades. Then when you go over the moving blades, which have the shape of an airfoil, okay? Due to the airfoil shape, when water will go over them, you will have a pressure drop of water over the blade. And this pressure drop will create a force, that a thrust force that can rotate your blade, okay? And in this case, when you are moving on the moving blades, you have two effects. You have the pressure drop that will help in rotation, plus you have the conversion of kinetic energy of your flow into rotational energy. So in the moving blades, you have a double effect that will lead to the rotation of your turbine blades, which is the pressure drop over the blades plus the transformation of kinetic energy into rotational mechanical energy. In this way, we have converted the energy of the flow of jet of water into mechanical energy of rotation using this design of turbine. Okay, and the opposite direction of the blades will help to increase the efficiency because you are redirecting the flow, so the kinetic energy will be transformed into rotational energy. Now, another very important invention is steam engines. Okay, and the concept of steam engine is that it will rely on transferring energy, heat energy into rotational energy. So always you have same concept. I am going to a design that allow me to change from one form of energy to another. Okay, so basically steam engine will transform the thermal energy, because when we talk about steam, so we have a very high temperature. Okay, so we have a lot of energy in the form of thermal energy. This thermal energy will be used to be converted into work through the steam engine. Okay, so it consists of a hollow metal sphere filled with steam and supported by two pivots. The momentum of the steam jet will cause the sphere to rotate. So you are converting the kinetic energy of the steam jet into rotational mechanical energy. And from the invention of steam power, we have the start of the Industrial Revolution at the end of the 18th century. Okay, now a very important thing is to know the concept of pressure, because as you have seen, we are talking about, let's say, pressure drop, because pressure, when you have a pressure and flow, it's also a form of energy. It's called flow energy. So a flow of high pressure represents a high potential of energy, because if you reduce the pressure of this flow, then you can convert the flow energy into another type of energy, which can be potential, kinetic, and then, as in the case of the first turbine of Fourneron, it is turned into kinetic energies, and this kinetic energy will rotate the blades up. Okay, so in order to know how to measure pressure, we should understand the concept of barometers. Okay, so this is a very simple device that will allow us to measure pressure in a fluid. Okay, so let us consider, for example, this is a mercury barometer. So
هي مشغلتها ما فيها شيء خيي، فرطنا لها بوزة كلها بنص ساعة بركي ورجعنا ركبناه بنص ساعة.
Can you please mute your microphone?
لأنه أول مرة يعني.
دقيقة.
Okay, so if you want to measure pressure of a fluid, you can use this device. This device consists on the following idea. Pressure in a fluid is the same at any, if I am working at the same level, so you have a theory saying that if I am in one fluid and I am moving on a horizontal level, okay, the pressure is the same everywhere. So if you look at the figure here, you have the atmospherical pressure. So here at this level, we have P. For example, here's the atmospherical pressure. Or you can have in any room, if you want to measure the pressure in a room, it might be different than P atmospheric, and you want to measure what is the pressure in this room. So you will take your device, okay, and you will see how you can deduce from the height of the column of fluid what is your pressure, okay? So what is the idea here? For example, let us consider that this device is in the atmospheric, is placed in an atmospherical room, where you know that the pressure is the atmospherical pressure. How can you determine what will be the height of this column? Okay, it's based on the concept that all points on this level will have the same pressure. So the pressure here that is equal to the atmospherical pressure will be equal to the pressure at this point. Okay, guys, the session will end. I will open a new one and send you a new link. Okay, so I will send you again a new email.